Okay, so hope you're well and everything is good from your side. Yeah, I
Yes,
hope you
yes, yes.
already get that first day's recorded class. You already get it for that topographical
Yes.
mapping. The previous class we already discussed about that how we can easily create the 3D map or 3D hillside map, in arc map or arc scene. So this type of work I hope now we can easily do. So today's session I can discuss about that mainly weather monitoring in remote sensing. Okay, as well as we also discuss about that prediction, how we can easily predict the weather data. So different types of AI model such as CNN, mainly convolution neural network, or also we can apply that recurrent neural network. So different types of neural network we try to apply in this case, and also further we also try to make the model and also make the prediction for the future weather condition. So let's go, let's start step by step. I hope we can easily get that all of idea and also apply. So let me share my screen. Okay, can you see my screen?
Not yet. It is coming. It is coming.
Okay. Let us go. Okay. So welcome to the weather monitoring and prediction using remote sensing with AI. I hope in this time just you will try to explain all of details from beginners to advanced level, and I hope you can easily monitor the different types of weather parameter and further also predict using the different types of neural current network, neural network. If you want, you can also use the different types of model. We also try to explore one by one. I hope you can easily get this idea. So first of all, I will try to display about that Google Earth Engine. Okay, so basically you already completed one online training program for Google Earth Engine. So in the Google Earth Engine, we can easily find out different types of weather and climate data. We can easily find out in Google Earth Engine data catalog. Okay, first of all, I try to explain all of data, which data we find out from the Google Earth Engine only for the climate and weather. Okay, then we try to also use this type of data. So basically, weather data and climate data set. So this is the reanalysis data. So this type of reanalysis data we find out in Google Earth Engine. So one data called that,
Sorry, sir.
yeah,
Sorry, sir.
please.
Can you maximize the font size? The screen is very small.
Okay, just a minute.
I can't read. Oh, it is a setting
How is it
in
okay?
my computer. Yeah, now it is okay. Now it is okay.
Right. Okay. So basically, find out that selected weather and climate data set. Basically, this type of data set called the reanalysis data, and we find out that ECMWF ERA5 daily and monthly data set is available, as well as ECMWF ER5 land hourly and monthly data set available, as well as NOAA CFSR, then also NCEF NCAR reanalysis data. So further I also try to explain all of data one by one, then you can easily get the idea what is the meaning about that ECM WF ER5. You can easily get this idea. And then weather forecast data. First one is the reanalysis, then you also find out that weather forecast data. So basically weather forecast data, you find out that NOAAS, GFS, NOATRMA, as well as ECMWF, CAMS, global near real time optical depth and particulate matter. Then also we find out that climate projection, mainly CMI, P5, NEX, GDDF. So this type of data reanalysis weather forecast and climate projection. So different types of data we can easily find out in Google Earth Engine data catalog. And further we also monitor the weather and also predict the weather. So let's go try to explain one by one all of details. So now first of all, ECMWF ER5 daily and monthly. So basically ERA5 is the fifth generation of ECMWF atmospheric reanalysis data, and it combines the model data with observation to provide a comprehensive weather story. And this is the ECMWF full meaning is that European Center for Medium Range Weather Forecast. So this is the full form about the ECMWF, European Center for Medium Range Weather Forecast. And this is the ER5. ER5 mainly it is the fifth generation of European Center for Medium Range Weather Forecast, and it combines the model data with observation to provide a comprehensive weather history, and it available from 1950. Okay, so this weather data we find out that 1950 to present time, enabling long-term weather and climate studies. We have just used here the ER5. This data very useful to when you want to find out the long-term data and climate studies. We just use here the ER5. Mainly it's the fifth generation of European Center for Medium Range Weather Forecast. Then we can easily use this data, and we can easily get the data from 1950 to the present time. And then variable monitor. So basically this data atmospheric parameters such as temperature, pressure, humidity, wind. So this type of atmospheric parameters we can easily monitor using this data, as well as land surface variable such as soil moisture, then evaporation, then surface runoff. We can also monitor using this data, as well as ocean related variable, suppose sea surface temperature. We can also monitor using the ER5 dataset. It also available. So basically these three types of parameter we can easily monitor using this data. Atmospheric parameter such as temperature, pressure, humidity, and wind, and land surface variable such as soil moisture, evaporation, and surface runoff, and also ocean related variable, sea surface temperature. We can also monitor using this data very easily. So further I also try to explain all of details one by one. I hope you can easily get this idea how we can easily monitor. An application of ERA5 data. So there are a lot of application such as weather monitoring we can easily do. For the tracking the temperature, we can easily tracking the temperature, precipitation, or storm pattern over time. Suppose you want to monitor the storm pattern over the specific time period. Okay, so this type of things we can easily monitor different types of weather parameter using this data, as well as climate analysis. We also use the data such as studying the long-term climate trends, drought, or extreme weather event. We can easily monitor using the data, as well as hydrology. There are a lot of uses also hydrology this data, such as water balance analysis, soil moisture, and flood prediction. Sometimes you also use the data for flood prediction. ERA5 data it also available to that. And also energy sector such as wind and solar energy potential analysis. When you do, then you also use the ERA5 data for that wind and solar energy potential analysis. We are also use this data. So this is the sector also I mentioned in here. And also agriculture such as assessing the drought impact, rainfall, evapotranspiration for crop growth. We also monitor using this data. So this is the application. Here I mentioned some application, and I also send you this type of slide also. So further you also try to read it, then you also get that more better idea. After completing
Thank
this
you.
class, I also send you this type of slide. And
Okay,
now
thank
this
you.
is the another data. So it's called that climate forecast system reanalysis. Okay, so CFSR. Okay, CFSR, it's the climate forecast system reanalysis data. This is the full name about that, and it's developed by National Oceanic and Atmospheric Administration. Okay, so this is the NOAA meaning. This is the National Oceanic and Atmospheric Administration. It's the developed this data. And CFSR, it means that climate forecast system reanalysis. And purpose, so basically a reanalysis product that provide the climate data for atmospheric, oceanic, and also we find out that long land components at the high spatial and temporal resolution. We also use this data. And also time span, so it also available from 1979 to present time. We easily find out this data. So climate forecast system reanalysis data is available from 1979 to present time. And temporal resolution, basically we find out this data for hourly. Suppose you want to monitor it for hourly or also daily or monthly. Okay, three temporal resolution are available for this data. We find out the data for hourly, daily, and also monthly. And data parameters, so basically climate forecast system reanalysis is provide the different types of parameter such as atmosphere parameter, pressure, temperature, winds, and humidity we can easily get from this data, as well as oceanic data such as sea surface temperature or ocean current. So it's very important for the ocean current. We also get the data, also ocean currents from here, as well as we also get the land data such as soil temperature, soil moisture, and snow depth data we also get from here. And also surface such as precipitation rate or radiation and flux data we also get from this data also. And this is the another data, so it's called the NCEP and NCAR reanalysis data. So basically NCEP means that National Center for Environmental Prediction. NCEP means that National Centers for Environmental Prediction or National Center for Atmospheric Research. Okay, NCAR. So this is the full form about the NCEP and NCAR. And to reconstruct the historical weather and climate present from 1948 to present time. So basically this data mainly reconstruct historical weather and climate pattern from 1948 to present time. We can easily use this type of data. And also this is another data, NOGFS, basically global forecast system. Okay, global forecast system. So this is the global forecast system is the weather forecasting model developed by National Oceanic and Atmospheric Administration. So this is the global forecast system, GFS. So this is another data, as well as to produce the weather forecast based on the global atmospheric and oceanic condition. We also apply when you weather forecast. We also use data. And also NOAA RTMA. So this is another data. So basically this is the real time mesoscale analysis. Okay, RTMA means that real time mesoscale analysis is a high resolution near real time weather analysis system developed by National Oceanic and Atmospheric Administration, and it provides the fine scale analysis of current weather condition for short term forecasting and real time application. We also use the data NOAA RTMA, mainly real time mesoscale analysis data. And also this is another data, ECMWF CMS global near real time. So basically this is the full form. It means that Copernicus Atmosphere Monitoring Service is operated by European Center for Medium Range Weather Forecast, and it provides the data on atmospheric composition such as air quality or climate forcing. So this type of data or atmospheric composition. So this type of data we can easily find out from the Copernicus Atmosphere Monitoring Service it provides, and it delivers the global near real time atmospheric monitoring. And finally, this is the another data, CMI P5NEX-GDDP. So in this data, it means that coupled model intercompression project phase 5. So this is the full form about the CMI P5 coupled model intercompression project phase 5, and a global climate modeling initiative coordinated by WCR, mainly World Climate Research Program, and provide the multi-model. We can easily apply the multi-model climate projection for historical and future period. We can also do it. So basically this slide I also send you. From this slide you can easily get all of data information. So now we'll try to discuss about the practically how we can easily use this type of data and monitor the weather. Okay, so let's go. Okay, can you see my screen?
Yes, I
Okay.
can see it.
Okay, so let's go. We'll start one by one. So basically, I just explain all of data information. Okay, so further I also send you this slide. You can also read it. Then you also get the more better idea. So now one by one,
Yes.
all of data I try to use, and further I will show you that how we can easily monitor the weather and also climate data set. Let's go. And further let's discuss about this model. So basically, recurrent neural network, and further we also try to prediction. Okay, so any data, so using this process, just you can simply modify this code and you can easily monitor the prediction for weather, different types of data using the recurrent neural network. So further class I'll discuss about that LSTM, this type of model, and also other time series model for prediction we also use. Then further I hope you can easily get this idea how we can easily work with the prediction, how we can easily get this. Basically this is the same approach further we also use for any kinds of model. So I hope if I just explain one model, then you also try to apply the same process for other weather parameters also. Okay, so let me open my code editor. Okay, so you just,
Sir,
yeah,
sorry.
please.
Is there any difference of? Yeah, I've seen that you were using that code, the last code you were visualizing them through the Python in the Google Colab.
Yeah.
Is it possible also the same process to be used in the JavaScript?
Okay, so basically in we just integrate Python, because Python is a lot of powerful library. Okay, so that's why it very easily we can integrate with Python, because neural network or convolution neural network, actually deep learning or different types of AI model, we can easily integrate in the Python library. So that's why in this case we simply integrate the Google Earth Engine and Python at the same time. Okay, so Python and Google Earth Engine we just simply combine, and further you also make the analysis. Okay, in the JavaScript
Okay.
is also possible, but it's not. Suppose when you apply the JavaScript, then we have to use the paid version. Okay, so basically when you apply the deep learning or artificial neural network or CNN or ANN, so this type of model, when you apply this code editor, then we need to buy we need to use the paid version of Google Earth Engine. But we can easily
Okay.
integrate the Python, and freely we can apply the different types of CNN or RNN or ANN. So this type of model we can easily connect with the data, and further you also make the analysis. Okay, so that's the
Okay.
region we are also use the Python, because we can easily use the freely when you want to use the Python. Using the different types of AI model or deep learning model, we can easily do you when you just use the Python. But JavaScript it's not possible, because JavaScript have this type of model CNN, we have to use the AI vertex. Okay, and when you want to use the AI vertex, then we need to buy their cloud storage or different types of paid version into use when you apply the CNN or ANN model. Okay, so let's will
Yes.
start.
Thank
Okay, so let me open my new code editor. So let's go start. So first of all, we are just simply search here. Yep. So just click on here. Here you can see we find out the lot of data, mainly ER5 land daily. So it's provide the daily information, daily aggregate with the ECM, WF, climate reanalysis data. Also you can see the ER5 land monthly aggregate, ECM, WF, climate reanalysis, or ER5 land monthly averaged by half, by hour, by day, ECM climate. So it show lot of data. Okay. So further you also try to read this type of data description. But when you work with this type of data for monitoring the different types of parameters, just apply the same process. You can see global land data assimilation system, Sentinel-5 NRT, mainly it's provide the near real-time cloud. Okay, so when you check the cloud near real-time, then you can also try to use the data. Then you can get the information. Okay, this is the cloud near real-time data. Okay, also you can see the this is the precipitation data. Okay, mainly it's the sharp satellite imagery. Climate has a centered infrared temperature with station daily temperature to the temperature. Okay, also you can see the near also, so you can see you can get this type of data. So now I just click on here for the daily, and we can easily find out the all of information about that. And this dataset provider is that you can see the Google and Copernicus climate data storage. Just click on, you can get the all of information about that dataset. Okay, so you can see this is the data about that. It's the program of the European Union. You can see ER5 post daily statistical pressure from 1940 to present time. Okay, updated today. Okay, updated today. So it's the daily data. So that's why you can find out that every day data we can easily get from here. So in this case, this type of data simply we can use using the Google Earth engine. But if you want, you can also download this type of data from here also. Okay, you can see the download. You can see the reanalysis data. So we can find out the variable. At least one variable you need to select. So you can see different types of data. So diverge, geopotential, potential velocity, specific cloud ice water content, specific humidity, U component of the wind. Also you can see the ER, it available from 1940 to 2024. Okay, so if you want, you can also download this type of data also from here. Okay, suppose I need the relative humidity, just click on the relative humidity. Suppose I need this data for year of 2000, suppose 2023. And also you can see the which month you need. You can also at least one you to select. Suppose I need the suppose January and December. Okay, just I select the two date. Also you can see at you need for January and December what the time or which day you want to select. You need the all day, just simply select all of day one by one, simply select all of day. Okay, so this is the process for randomly. We can also download the randomly from the Copernicus EU website. Okay, we can easily get all of data. But in this case, we also try to use the Google Earth engine and download this type of data and also analysis and also make the map. Okay, also you can see the pressure level. So you can also select the pressure level about this data, or daily mean, daily minimum, daily maximum. Okay, suppose when you calculated the average, then you can simply select the daily mean. When you need the data for daily minimum or daily maximum, okay, so simply select. And further you can simply choose your time zone. Okay, UTC, suppose it's a +6, simply select that. And frequently, suppose you need the data for 3 hourly or 6 hourly or hourly. Okay, as well as you can also put your specific region. Okay, suppose a specific north, south, west, east, also, and then simply download. Okay, and before the download you also need to registration. Okay, login register to accept the license about that. So this is the data provided the ECMWU app we can easily get, and it also provide the atmospheric data store, as well as it also provide the early warning data store. Okay, CEMS, early warning data store, we also get from here also this data. Okay, so this is another, you can see this is the CEMS. So from here we can get the another types of data tracking. Is just accept all. So here you can see, if you want to check the live, suppose live data management or live, just click on here, then we can easily get, you can see. So now user rating 1, so you just need to registration. Okay, then you can easily get the data, and how much people download the data for different time period, you also get this information from here. Okay, you can see download the data last hour, download the 3 GB data from here. Okay, mainly number of requests 50, number of users 6. Okay, so also they are download this type of data. You can see the CMS global forecast, also global for historical. Okay, also fire historical data. Okay, different types of data we can easily get it from here. You can see how much country Netherlands download that 33 GB, from the Denmark download that 19 GB, Germany. So it also provide this type of information. So his country download his information, how much information, you can easily get it from here. Okay, as well as you can see the graph. So this is the information about that, how much people download their data. Also in the data set, so you can easily find out, you can see seasonal reforecast for river discharge and related data from the global food awareness system. Okay, also you can see reforecast for river discharge. Okay, so basically this is the river discharge that you can also download from here. River discharge related forecast data by global food awareness. So further you also try to read this type of data and also try to download it from here. Okay, also you can see the fire danger indices, historical data from the Copernicus emergency management service, river discharge. So it provides lot of data we can easily get from here. So maximum data is the globally available, no problem. Seasonal forecast of the danger indices from the Copernicus. Okay, we also get this data from here. Okay, so different types of data we also get from here. So you also try to read this type of information, okay, and also download this type of data. But in this case, we are just try to use the Google Earth engine. But all of data is not available in the Google Earth engine. So that's why you also try to check this type of website or this type of information. Then you can easily get that all of data for that. Okay. So let's go. Okay, so this is the data. So basically it's available from 1952 present time. You can get the data and which type of information I get. So you can see we find out the dew point temperature above the 2 meter from the surface. We also get this data. Also temperature 2 meter, mainly we find out the temperature from above the 2 meter. Also you can see about the skin temperature. Okay, also you can see the soil temperature level 1, soil temperature level 2, soil temperature level 3, different types of level. Okay, lake bottom temperature. Okay, a lake ice depth, lake ice temperature. Okay, lake mix layer depth. Okay, different types of information you can easily get from here. Snow cover, snow density data you also get from here. So you can also read this type of information, then you also get a lot of idea. Okay, suppose I want to use the data and further I want to work for, suppose I want to monitor, suppose temperature. Okay, I want to monitor for the temperature 2 meter, and it means that you can see temperature of air. It's not surface temperature, it is the air temperature. Okay, temperature of air at 2 meter above the surface of the land, sea, and inland water. Okay, 2 meter is calculated by the interpolating between the lowest model level and that surface and taking the amount of the atmospheric condition, and this unit is the Kelvin. Okay, unit is the Kelvin, so we can easily convert into degree Celsius also. So this data I want to use and then monitor the temperature, air temperature, because this is the air temperature provided above from the surface above the 2 meter height. We can easily get the data and we can easily use it. So let's go how I can use it. So very easy, just I copy the band and import. You can see import the collection. So if you check how much images are available in this collection, that the print and call this. I just put here short name. I here suppose data at this data set. So now I want to check how much image is available in the data set. Just use here the dot size function and then check how this is available. So now it computing. We find out that this is the total imagery is available for this data. Basically ECM, WF, ER5 plan data. And from this data, I want to work only for the specific band. I want to work only for the temperature. I want to work only for the temperature 2 meter. Okay, from the above the surface, we try to use this data. So further, just I take a variable. Suppose I put here the temperature. Take a variable name temperature, and call my data set and use at the size. The select function. Select specific band which band I want to work. I already picked. And now if you want, you can put this time period at this time. So I put here that and put the time. So all January from get the 20 31. I want to make this analysis with time period 20 years data. I want to one can simply put one specific time. This is now after doing this, how much image can call m at the size function. So now it provides that between this time period how much is available. We find out that 7,670 images are available. So now this is my image is available, and I want to use this image, and further I want to calculate the temperature as well as also calculate the temperature trend. Okay, so it's mainly air temperature. Okay, so let's go. We try to calculate that temperature. So just I take a variable. Just I want to make that suppose a chart, a temporal chart, and it provides the daily chart. Further, we also discuss about that how we can easily make the monthly chart as well as also annual chart, and also check the trend. What is the trend about this day by day temperature increasing or decreasing for a specific region? Okay, so making the chart we already know about that code. This is the UI chart dot s dot this, and in this we already make the image collection. Okay, we find out that this is our total image collection, and this image collection is already stored in a variable. This variable name is the temp. Just I simply copy and paste here. So now region, so basically which area you want to work for. Suppose in this case I simply study area, and before that I already imported my f file. Suppose I want to import I want to import that whole country boundary of Bangladesh, and I put the variable name suppose ROI. So now further I share ROI. It's my study area. For this study, I want to calculate average. I put here E dot reduce dot mean. So it calculates the average temperature. And further, if you check this analysis dataset relation, that we find out that this can use here X property. It's just type here time. Further, I just take a example that chart and between the so now it computing the chart, and from the chart we can find out the data. Mainly it provide the daily data from 2000 to 2020. So in this case we face this type of problem. You can see we find out that error generating chart user memory limit exists. So it means that we exceed the limit. Okay, so for that in this case we also need to apply, we can also download the data as a csv file. Okay, suppose when you face this type of problem, then we need to if you want you can also shorten the time period. It also possible. Suppose in this case I just take only for the 10 years. Suppose I just put here the 10 years. It also possible. But if you want you can also download the data csv file. Suppose I just download all of data at the same time without creating the chart. Just download the CSV. So further also discuss about that how we can easily make the CSV file. So now you can see it show the 4000. Okay. So before that it will be 7000. So it across the limit 5000. When it will be across the limit 5000, then we get this type of error. Okay. Chart is not created. But it also possible we can easily download the data without creating the chart. We just simply download the data CSV file. Okay, as a table. It also this type of problem again. Okay. Okay, let me take for the 5 years and then check what. I think problem. Okay, let me change my study area and then check what happened. So I simply put the Dhaka study area and then remove the previous one. I put here suppose ROI. Okay, but this problem we also put the another solution. You can simply download the data as a CSV file. Then I hope it will be worked. Okay, so now you find out this type of result for the 5 years data. Okay, so let me try for 20 years for the small study area. In this case, I just put only for the Dhaka city boundary. Okay. Now let's check. Because when you want to apply the big study area, then we face this type of problem. Okay, chart is not created. But when you want to apply, okay, it also not work. Okay, let me take for 10 years. So now it also works. Suppose I just keep for the 10 years and it show about the air temperature. Okay, and we find out that it show the Kelvin unit. You can see the chart show as a Kelvin unit. Okay, but I want to need this data for that degree Celsius. Okay, so now I talk about the conversion, how we can easily convert the unit Kelvin to degree Celsius, and then we can easily make the time series chart as a degree Celsius. Okay, for the 10 years data, 10 years daily temperature, 10 years daily air temperature data, how we can easily convert. So let's go, I talk about that. For converting this unit, we just create a function. Okay, we need to create a function, and in this function we just simply apply we need to apply the formula, mainly Kelvin to degree Celsius. This formula when you apply, then it will be okay. So let's go try to create this function. And you already completed my one online training program, so I hope you already know how we can easily make the function JavaScript program. So for creating the function, just take a variable. Suppose I put the variable name is that Kelvin Celsius. You can put any name. So now create the function keyword. So I put the function keyword and I put take a element name. Element name, basically you can put any name as a variable element. I put this name, suppose img, and then put this curly bracket. Curly bracket, I just need to put my argument. What is my argument? My argument is that this element I want to convert into degree Celsius. Okay, so for that I want to return, just put here the return this image subtract with a value 273.15 this value. So basically when you subtract this value, if I simply search on the Google for Kelvin to Celsius, so when you subtract this value, you can see when you subtract this value, then you can easily get the result in degree Celsius. Celsius is Kelvin value, subtract with 273.15 value. So when you subtract this value, then we can easily get this result in degree Celsius. Okay, so for the region, just I simply subtract this value from the Kelvin, and I want to apply these properties all of images, mainly total 4017 images I want to apply all of images. So for that, simply use at the copy properties, yes, and then just I apply it time start to same time in. So this is my function. Okay, so this is my function, and this function I need to connect with my data set. So this is my data set. Okay, just I simply copy and then paste here, and for connecting just use here the map function, and further I just create the time series chart using this new variable copy and paste. So now try to check what happened. So now if you check this temperature, just click on here. We get this type of result. You can see now it show about the degree Celsius, and this we find out the air temperature. Okay, this type of data. Now it show about the, it show the daily. Okay, we find out the daily temperature from year of 2000 to 2010. This type of data. Okay, this same data set we also use in here in the Python. Okay, because Python have some powerful library, and this library we can easily use, and further we also try to apply different types of neural network, suppose recurrent neural network, artificial neural network, or convolution neural network, and also do different types of, create the different types of model. So if I just show you the, I also try to, so you can see this is the another data, same data we also use in here. Mainly it's a mean 2-meter air temperature data. In this case I just take the data from 2014 to 2018. Okay, and further based on the data we try to apply the RNN. So basically this is the recurrent neural network, and further also predict. So this chart we also created. In this case we are just use this code in Google Earth Engine, and we can create this type of chart between this time period, and it show about the degree Celsius. This same task we also do using the Python, because Python have some powerful library, and this type of library we can easily connect with the different types of model for the prediction. Okay, so further I'll also explain about that how we can easily work with that. Okay, so let me, okay, so now we find out this type of time series chart. So now I want to check what's the trend, what's the trend of the air temperature between this time period 2000 to 2010. Okay, so what is the trend about that? We also check the trend also from Google Earth Engine, and further we can take the decision for the air temperature day by day, this temperature is increasing or decreasing. Okay, so let's go try to discuss about the trend. Okay, let's go. So for the trend, when you apply the trend, we can, okay, so before that we also need to add some information. It show the about the average, it just only show about the average temperature. Suppose I want to find out daily minimum and maximum, daily minimum and maximum temperature value I want to need. So for that, if you want, you can simply put here that max, then it show the result for maximum temperature, maximum air temperature in a one day or single day or each day. What is the maximum temperature? We can easily find out from this analysis, from the chart. Now it show about that each day, mainly it show about the maximum temperature. When I just use the EE reducer dot max, it show the result maximum temperature. When I put at the mean, it show about the minimum temperature. Sometimes for the different types of analysis, it show about the minimum. But if you need, suppose max, mean max, so in this case at the same time I find out the mean function max, at the same time we find out the minimum and maximum. We just click on here. So just download the data CSV. Now let's check the data from here. You can easily find out Okay, so it find out that almost same temperature. Um, at- okay, so we try to check for average trend at the mean. And now now if you want, you can simply add here the other information. Suppose I want to check the trend and also set the trend line. So for that, just if there dot set option, and you also put some, some information, title, chart title, title some air temperature. To further put at the vertical axis. Yes, please.
Air temperature is the same to wind temperature.
One.
Air temperature is equal to the wind temperature. Wind temperature. Is there any difference?
Well, minimum and maximum. Huh?
No. I'm asking that air temperature. We are dealing with air temperature now, is it?
Yeah, it's air temperature. Yeah.
Yeah. Now I'm asking air temperature is the same to wind temperature. Wind temperature.
Yes. Wind means air.
Okay.
The air, and this air height, that surface above the 2 meter
Okay.
height.
2 meter from the land surface,
Yes,
is it?
yes.
Okay.
As well as we further the discussion, we also calculate this technique.
Okay.
Further title I put here, it's a time. Okay. Further, if I run the code, get all of you can easily find out, you can see all of information added in here. So you find out that air temperature, time. Now from here we try to check about the trend. What is the trend? This data set have any trend or not? We also check it from here. So for the trend, we just create the trend line. The trend line can be automatically generated for a scatter bar or column or line chart. So it's the line chart. So in the line chart, I want to generate a trend line. So let's go. For the trend line, just use the one argument. It's called the trend lines, and further just put curly bracket, and then put at the 0. Okay, 0 mainly serial number. So in this case, we find out only for the one line. It show for the only for the one line, and so that's why I put at the 0. 0 refers to the first item. So in this case, it's just only for the one line. Just I put it at 0, and I put here the information for that. So first information is the type. Okay, what is the type? Type mainly linear line type. We use at the different types of linear trend line, such as polynomial or exponential or linear. Suppose I put here the type is the linear. linear for the trend line. So I put here the linear, and then if I just run the code, what happened? Syntax unexpected token. Just run the trend line. We just take this. Let me check what some problem for writing this quotation. So it will be start from here. Trend lines I want to add bracket. For the first line, just put it the 0. After that, first one is the type, the types of okay, so it's okay. Now run the code. So I find out that this type of trend, just I click on here. So you find out, you can see this trend line is increasing. Okay, so it show about that increasing. Okay, increasing. So it means that day by day this air temperature is also increased. Okay, because we find out the uptrend. So further we also add the more style for the trend line. It look more better. Okay, so let me add the code. Yes. Okay, so we can also define the trend line color as well as also define the trend line with opacity. You can also do it. Suppose I put here that color. Suppose I put the trend line color as a suppose green color, and then put here suppose line width also increase line width. Suppose I put the line width is that 4 pixel, and then run the code again.
Trend line means that the horizontal line are crossing through the values.
Yes. There you can see, find out that it also show the result, it increasing. Okay, so day by day the air temperature is increasing. Is this trend line means that. Okay, So it's one kind of global warming. So day by day temperature, air temperature is increasing. Okay, we find out
So
that.
that line is not horizontal. It is increasing. It is just like some diagonal. Is it?
So this is the region is that mainly for Dhaka city boundary. We already import our study area. So it means that for
Yes.
the Dhaka city boundary, between this time period 2000 to 2010, for this 10 years,
Mm.
when you just analyze it only for the 10 years, we find out that between these 10 years, this time series analysis, when you do from the trend, we find out that temperature is increasing day by day, it increasing. We find out the uptrend. Okay, and we find out that you can see, oh,
Okay.
okay, let me add the legend, it will be more better. So I also add the legend for the trend line legend, so we can easily find out that we find out the positive value for the legend. So for that, just add the visible 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 in legend, visible legend, just put at the true. So now run the code. It also visible that also that's legend also. Now if I just also find out that, you can see we find out that it show the result 13.58 plus 13.548. So this value, so we find out that every single day it also increasing, it increasing this value. Find out that 13.548, 13.548, 13.548. So it find out that increased, okay, day by day this temperature increased. Okay, for this study area, air temperature increased, we find out that. Okay, but when I find out that negative, suppose I put at the negative, suppose plus, it show the negative result, it means that we find out the increase decreasing day by day, day by day we find. And then we find out the low trend, it show the low trend, but in this case it show the high trend. So you can see it will be start from here, you can see, and end in here. So it increasing, it show the uptrend, we find out the uptrend, it means that increasing the temperature, air temperature day by day increased. Okay, so now we find out this type of result, and the way we can easily check the trend also from here. So in this case we try to use the data, basically this data we try to use it here. So in this data we can easily show our band. So in this case, suppose I choose for the temperature 2 meter, about that. So basically it's the temperature of the air at the 2 meter above the surface of land, sea or inland water. 2 meter is calculated by the interpolating between the lowest model level and the earth surface. Not only for that, we also get the other information in temperature and temperature of the surface of the earth. Okay, surface of the earth, or LST, the land surface temperature, it's called the skin temperature. Okay, the skin temperature is the theoretical temperature that is required to satisfy the surface energy balance also, and it represents the temperature of the uppermost surface layer. Suppose LST, which I know, then it called the skin temperature, is calculate the different over lands. It also same, suppose you want to work for the LST, then you can easily work with that data. As well as you can see this is the temperature of the soil in layer, suppose 0 to 7 centimeter is the first layer. Okay, 0 to 7 centimeter is called the first layer. Also you can see the 7 to 88 is the second layer. Suppose you want to monitor the soil temperature, it also possible, you can also use it. But for that, you can see, find out the different types of depth. So we find out the first layer 0 to 7 centimeter, second layer 7 to 28 centimeter, third layer 28 to 100 centimeter. So different level we also find out. So basically which level you want to analyze, just simply work with this band. And it also same for the Kelvin. Okay, as well as this is another data, temperature of the water at the bottom of inland water bodies such as lakes, reservoir or river, and coastal water. And this data is implement a lake model, 2015 to present, of the water temperature, lake ice, all of the world's major inland we can easily use. As well as also you can see this is the another data. So this is the thickness of ice and inland water body, also use it, thickness of the ice and inland water body. such lake, reservoir, and water and coastal waters. This unit is the meter, okay, and single ice layer is represent. So you also read this type of things. You also get a lot of information. This is the temperature of the uppermost surface of the ice inland water bodies, coastal waters. Okay, also Kelvin, and you can easily convert into just apply the same process. Because it provides a lot of data. Just click. This is a catalog page. Soil level, all of information. Sono depth, you can also monitor data depth means that meter. You want to calculate the snow density, then you can easily use kg per meter cube. You also calculate the snow density also, or snowfall sum, temperature of the snow layer, or reservoir content, forest forecast albedo, surface latent heat flux sum. So exchange of latent heat with the surface through the travel and discussion. It provides a lot of data. So basically the reanalysis, we find out the lot of data. Also run of sum, a potential evaporation. You also calculate potential evaporation in the current ECM model is computed. Okay. You also get the description about that. Surface runoff. Okay, suppose you want to monitor the surface runoff, some water from rainfall, melting snow or deep in the soil stay in the soil. You also calculate using that. As well as you can see, we also find out that speed, that wind speed. Okay, we find out that U component of the wind 10 meter and also V component of the wind 10 meter. So if you know the U and V, then you can simply put the speed formula and calculate the also. Suppose I'll show you the example one about that for the wind speed. Because in this case, you also need to apply the formula y square plus v square square root of y square plus v square. When you apply, then you can easily calculate the wind speed also and monitor where the high wind speed. You can easily get it, and it's very useful. Monitor the storm or cyclone tracking. So I will show you the one example for cyclone tracking. Then you also get the idea. Just in previous code. Okay, just I run it. For the cyclone tracking, you can easily find out that in the center of the cyclone, you find out the very high temperature. Okay. So in this case, in this case, you also use this data. You can see ECM W daily. So same data we also use because this data provide you that U and V. Okay, we find out this information. Same data we also use in here. Okay, so just I run the code and show you the result first. Okay, and we also try to use the another data set. It's called the MODIS. So basically, we just also find out the MODIS true color, and then we can easily find out. Suppose this is the coastal area of Bangladesh, and here we can easily find out this type of storm or cyclone. We can easily find out, and this is the cloud. Okay, this is the cloud information you find out in here, and you also check about that maximum wind speed. Okay, so you find out that this cyclone this is the place about that. So in this place we find out that maximum wind speed. Okay, and if you want, you can also put the cyclone center or information also, but it not need. But in this case, you just compare this data. So this is the wind, okay, or cloud. You can find out. In this case, we just use here the MODIS, and then we also maximum wind speed we also generate from here, and then we can easily track about that cyclone. So this is a cyclone. So now how I can create this type, I just explain about that. So for doing this thing, so first of all, we simply take our study area. Suppose this is our rectangle. We just a rectangle for our study area, and in this case, we also use the another important data set. It called the MODIS. So just I copy and show you the data set, all of information for the MODIS. This is the MODIS Trara ocean reflectance daily 1 kilometer data. So this data set you also use in here. Okay, so basically this is the data. This is the MODIS ocean reflectance daily global. So this product we can easily, when you apply the true color composite, mainly modis, you can see different types of band is available also for the modis. So just we use the data and use the true color composite, then we can easily detect the all of cloud, everything can easily get from here. So in this case, just I simply put my image collection, as well as we also put our time period. So basically when cyclone happened for this place. So just I put this time period and also filter bounds with my study area. And then I simply put here that RGB, mainly surface reflective band 1, band 4 and band 3 we just put in here. And then we try to create the median composite and clip with our study area. So now further if I just show the result, so we can easily find out this type of modis cloud. Okay, and this is the cyclone area. We find out this type of high cloud density. Okay, so it shows about the high cloud density we also find out in here. So now after getting this type of information using this modis true color, we just display, and further we also call the ER5. Okay, so basically this data ER5, this data, from this we just take the V component of the wind and also take the U component of the wind. So basically U component, it's the eastward component of the wind. It is the horizontal speed of the air moving toward the east at the height of 10 meter above the surface of the earth. Okay, so it height of the 10 meter above the surface of the earth in meter per second, unit is the meter per second. And this V component, so basically it's the northward component of the 10 meter wind. It the horizontal speed of the air moving towards the north and the height of the 10 meters above the surface of the earth, and also same meter per second unit. So these two things we need when you calculate the speed, air speed or wind speed. When you calculate, we need the U component, also need the V component. So for that, after using these two things, we are just simply we take the data. Suppose this is my image collection, and then we call the filter date. So a specific time period I simply put in here, and filter bounds with my study area. Okay, and I just call the two band. Which band I want to need? I need this band, as well as I also need this band. Okay, so wind component, mainly U and V. This wind component you need. So then further calculate the wind speed. So for the wind speed, so this is our formula. You can see U square plus V square and square root. Okay, so using this formula we can calculate the wind speed. So U square, mainly U, this is the U mainly, this is the U component band, V mainly V component band, and further we just check the speed. So how I can check the speed? So this formula is that Y square root of Y square plus V square. So these things we see mentioned in here for calculating the speed. So just put here the Y square, Y power 2 add V power 2, and also whole equation just put the square root this function, and I just rename it as the wind speed, and then I create the band about the wind speed. So further we calculate the maximum wind speed on the period, mainly cyclone period. Just calculate the max. So just I call the wind speed and select this wind speed band, because I make the wind speed band, and calculate the maximum wind speed, and I put this type of color, blue, yellow and red. So if I just open this, so we can find out that this type of red color indicating about the high wind speed. Okay, then yellow is the middle and blue is the low wind speed, indicating about the low wind speed. So this is the way we can also easily getting the any information for historical cyclone area. We can easily find out. Okay, just simply put your time, specific time, because this wind speed data is available from 1950. We can get the data from 1950. So between the 1950 to present time, any cyclone you can easily track or monitor. And we also try and find out that cyclone track line. So I also explain one by one all of the details. So I hope you can easily get this idea how we can easily calculate the wind speed. Okay, so in this case, same process you can also apply for calculating any place wind speed, but in this case just I mention with the specific purpose. Suppose cyclone tracking, we can easily find out using the wind speed also. Okay, so this type of code I also send you. Further, you also try to practice for your own study area. And this is a trend line.
Yes.
So now I want to visualize the map. Okay, suppose this is our chart we already discussed, and also calculating the trend line. So now I want to visualize this type of temperature, and I want to find out where the high temperature, where is the low temperature between this time period. Okay, for visualizing this type of information, first of all, we need to reduce the image collection. We just need to reduce the image collection, and further just simply visualize this way. Okay, so before that, we also try to discuss about that how we can easily create this type of chart using Python, because we can simply connect the Python with some AI tool. Suppose we can easily apply the deep learning, different types of neural network we can easily add. So for that, I just explain the code for that Python also. Further, we just connecting different types of AI model and also predict also. So let's go. I already write this type of code and also make this type of chart. So in this case, we also use the same data. This data mainly mean 2-meter air temperature between this time period. So how I can work with that? So basically, when you work with this type of recurrent neural network, we need to install some packages. Yes, we need to install the Earth Engine API package. We also need to install the TensorFlow package, or Pandas package, or NumPy package, or Plotly package, Matplotlib, Shapely, and Scikit-learn. So all of packages we just need to install first time when you want to work with the Python environment. So in this case, I simply install Earth Engine API, TensorFlow, Pandas, NumPy, Plotly, Matplotlib, Shapely, Scikit-learn, and then I run the code. So I again run the code again. It's actually done. And further, we need to also install the Keras. Okay, just run the code. So basically, we can easily integrate the TensorFlow class with Python. So that's why you can easily apply the different types of deep learning or recurrent neural network or convolution neural network. Okay, as well as I also need to just simply import all of those. Okay, so you can just Shapely import all of those as I simply just run it. It also done. And now we need to authenticate. Basically, in this case, we just need to connect with Earth Engine. Okay, so that for the region, just put here e.authenticate and run the code. So basically, it connecting the Earth Engine with your Google Colab. Okay, so now you can see, just simply click on the allow. Okay, just simply we connect Earth Engine server with our Google Colab, and then run it. And also continue. And further continue. And also mention your project name. Okay, so basically I already make the cloud project. So you can easily get the cloud project name from this side. You can see this is my cloud project name. So which cloud project you can find out in here, just use the same name in our cloud project. So just I run also it. Okay, so now you just define your coordinate, basically which place you want to work. So simply I take my specific city or specific latitude longitude value. Okay, and further I put here the scale of my resolution. So this is my resolution of my data. Okay, as well as I put the start date and end date. Okay, and also put the band name. Okay, so variables mainly state the band name, and location point I just simply take the x and y. X and y basically it's a coordinate. Okay, coordinate. So I run the code for my study area. I can get. Okay, and further I take a variable gre and I call my image collection. So this is my image collection. From this image collection I select the variable mainly it's my band name. Okay, I just stored the band name in a variable. So just I call the variable and I filter for a specific time period. I put here the time period, start date and end date. And further I simply get the region with the location point. Mainly this is my point, location point. I already create the geometry dot point, mainly x and y. It stored the specific latitude value and longitude value for my study area. And I just convert the data as a data frame. So just put, I call the PD mainly pandas, and put the data frame and data and columns. Just I run the code. You can see it also work. There is no problem. So after doing these things, we are just, you can see also subtract this value 273.15, because in this case we just work for the degree Celsius. Just I convert using this, just simply subtract this value. And further, if I just run the code, just we plot and also put the title, y level title, then we can easily get this type of time series chart. So it show the temperature and it show about the date. Okay, in this case these same things we also apply easily using the Google Earth Engine also. Okay, same thing we also apply. And when you want to work with Python, different types of powerful library such as Cross, TensorFlow with Google Earth Engine, then this type of chart we also need to create in the Python environment. So further we can easily apply this type of data. If you check all of data, just click on here, you can see I simply put the head function. We can easily get, you can see for that first January, 2nd January, 3rd January. For this coordinate, what is the mean air temperature, we can find out. Okay, for every single day. And if you want, you can simply click on here, you can see the convert data frame to the interactive table. So you also get this type of table. Okay, all of result you can get in here, sir. So we can easily get it, all of information. All can also create the chart, different types of chart also. Okay, and further, okay, you can see the 2D categorical distribution. It different types of things, you can really get it from here for this data. So it shows about the single day, because in this case ECMWF provide you the daily data. We can easily find out from here. Also you can see type of chart. We can easily create different types of, now Google Colab is also developed, so it easily suggests different types of information from here. Again, just on the code we can get only for the head. Well, you can see in the head basically it stored the date column, then ID, and also longitude value, latitude value, and also find out the you can see this is the temperature, mainly air temperature above the 2-meter height. Also get from here. Okay, so now in this case, okay, so I will try to explain later about that, mainly recurrent neural network weather model. But this is the process you just apply for any data set. Okay, so basically when you work for the other data set, just apply the same process or same code, just simply change the band name or other thing, then it also work very well, no problem for creating the chart. Further we will discuss about that recurrent neural network and also make the prediction for the future, what is the trend of that temperature also. Okay, and now Google Earth Engine, it only provide the trend. We can check the trend. Basically if I have a data from 2000 to 2010 for the 10 years data, we just analyze this and we can take the decision the air temperature is increased day by day in the Dhaka city boundary. Okay, so let's go try to talk about the visualization about our data. For the visualization, if you just click at the layer map.layer, and just how this data is for the whole working. I'm okay, it's also working. We find out the default color, black and white. Okay, so let me add the color. Then you'll some suggested color code. Add this color code. Just paste here. So in this case, it's not need. I remove it. Already quantified the unit. Position Kelvin unit. But here, let's subtract the value for the whole average the whole word. Let's suppose now run the code, then it was okay. Just I simply subtract the value 273.15 because previous result show as a Kelvin. Okay, so in this visualization mainly show you the result for Kelvin. But when I subtract these two value as a degree Celsius, we simply subtract 273.15. Then we can get the result in Kelvin. And just copy this variable name and add after the var name. World. On the code again. Now this color is set it with my map and find out type of. And we show the world temperature map time period 10. Loaded. I think some networking issue that's why it takes some time. Let me check the temperature. Just click on the Inspector tab and then click for a specific map. Suppose just I click on here. So now it show about the for this temperature. What is the value you find out for this specific coordinate? What is the value of the air temperature? So we found the 18.35. Okay, so now I want to work for a specific region. Okay, suppose I need this result for a specific country or a specific region or a specific boundary. So for that, if you want, you can suppose I need this result for Africa boundary. So only for this Africa region. So for that, I can simply import the Africa boundary shape file. Suppose I simply search here this data US data. So from here you can easily get the international boundary polygon. Just I import, and further just simply filter the data. Just I take a variable ROI, and then I call my table. This table simply filter. So I put here EE dot well, and I put here get the information. I want to use the all region or only for the Africa air temperature. Just put here that. So now this Africa boundary is stored in this variable ROI. So just I remove this here. And now I want to create this Africa boundary. I want to create suppose average temperature. I want to display for average temperature for the Africa boundary between this time period year of 2000 to 2010. Okay, 2000 to 2010. I want to check for average. So for that, just simply take a variable. Suppose I put the variable name is that mean air temperature. I call my dataset. So basically Kelvin to Celsius. This variable stored all of images. So now I just reduce. Just I put here the reduce function for calculating the statistical. So I want to calculate for average. So put here EE dot reducer dot mean. Okay, and further just clip with my study area. Clip with ROI. So now I want to display this average temperature here, and now run the code. So now this result is visualized only for Africa boundary. Okay, done. So basically minus temperature is not possible for this Africa region. Okay, so that's why now we also get the more better visualization. When I start the data, it automatically show you for stressing 98%, then we find out the range 11.29 to 31.83. This is the range. Okay, just I try to apply. So now you can got this type of map. Just I import. If you want, you can simply click on the import, or if you want, you can simply change the value. Suppose simply change the value from here. Just copy this value and paste minimum range. It's not the minimum value, it's just minimum range, and this visualization is generated between this range. Okay, just I run the code. Now you can got this type of temperature, air temperature. So now you can easily get it between this time period 2000 to 2010. 10 years average air temperature result. Okay, 10 years average. You can easily find out 10 years. So in this case, you can easily, if you want, you can randomly put, suppose you need the specific, suppose 2000, 2010, suppose you need only for the 2000, year of 2000. So simply put here the 2000, and run the code. So now this map is load only for the year of 2000. Okay, suppose you need the 2001, just put here the 2001, the January to December. So then we can get the remap for 2001. So this is the normal process. Okay, suppose randomly we just change the time, a specific year, it create the specific year average air temperature result. It also possible, normally we also do, but we also try to learn the another advanced thing. Suppose we just create a function, and this function help you automatically create it for average yearly or annually, create this type of things. As well as suppose you need the result for monthly. For the monthly, suppose I need this result for only for the month of January, so just put here 01. Then it easily create for the month of January. We find out the result month of January, but it's not the proper way, because I need at the same time I need all of month. Suppose 2000 to 2020, I need all of month. Suppose I need all of annual. Okay, suppose 2000, 2001, 2010, all of those annual result I need at the same time. I need to export all of result, but randomly if you want you can also do it. But in this case I also try to discuss about that how we can easily convert the monthly or annually, as well as how we can easily create the time series chart for annually. So in this case I just show you only for the one data, air temperature, but this same process you can also apply for precipitation or also other air parameters also. So let's check another example for precipitation, then I also back the code again. Let me open my code editor. So let me open my okay. So in this case, I try to explain about that how we can easily create the annual and monthly time series chart for the precipitation. Okay, basically in this case, I use here the chart satellite imagery. It provides you the precipitation information. So basically, we find out the painted and daily. So if I just show you the all of detail about this data. So basically, this is the data, and from this data, we can easily get the climate hazard center infrared precipitation with station data. Its full from is short from charts, and we find out the 30 plus years rainfall data from dataset. It's available from 1981 to present time, and this is the snippet ID. So basically, painted find out the data for 5 days, and you can see that millimeter per painted, but this dataset is also available for the daily. Suppose you want to monitor for daily precipitation, then you can also use at the millimeter per daily. In this case, if you want, you can also make the precipitation trend. Suppose you want to make the precipitation trend for your study area, a specific study area, just apply the same process for checking the precipitation trend for a specific 2000 to 2010 or any specific time period. To check what is the trend, just apply the same process. Okay, so I also give you some also assignment regarding this type of topic, so you also try, and further face any problem, then I also guide you how we can solve this type of assignment. So you can see, suppose you want to check for the what is the trend of precipitation or rainfall trend for your specific boundary, and also calculate suppose average precipitation result or maximum precipitation result or minimum precipitation result. Then just apply the same process on this data set. You can see this data set is also have a band name. It's the precipitation band. It just use the band and further apply the same process for creating the time series chart, for creating the trend of precipitation, and also download the data. All of those are the same process, and also create the precipitation map also same process. So in this case, I try to show you that how we can easily create this type of, you can see in this case it show this type of information. We find
Ah,
out that, yeah, please,
is
please.
it possible to download the precipitation data through CSV?
Yes, yes, yes. All of those are
It's
possible.
possible.
Yeah, all of those are possible. So we can easily
Oh,
download any data as a CSV file. Okay? CSV file is mainly neat when chart is not work. Okay, suppose you need the data for big study area, then we can easily
yes.
download the CSV file. I will show you that all.
Oh, okay.
So in this case, you can say I create this type of result. So annual precipitation, basically it show the result for total precipitation. Okay, suppose you can see January 2000, it's a 2000. Okay, whole 2000, not for that first January, whole 2000. Okay, this is the whole 2001, 2002, 2003, mainly annual total precipitation result. We can easily find out from this chart. It show the annual total precipitation. Okay, total precipitation we can easily get, as well as if you check the information, it's another information. From here you can easily find out the monthly. Okay, suppose 2000 all of month, January, then February, March, April, you can get all of month. You can also download the CSV file from here, you can see. But sometime when you work with big study area, then chart is not work. Okay, because there are a lot of pixel, your data set is so big, so then chart is not work. And when chart is not work, then we try to apply for CSV. We download the data directly in CSV. Okay. And when you predict the precipitation for a specific time period, then you also apply the same process. If you want, you can also apply the recurrent neural network, or if you want, you can also apply the LSTM. This type of method we can easily integrate using the Python. So that's the region. We also use the Python, Google Earth Engine code editor. Just simply connect the Google Earth Engine data, and then further we also use this type of TensorFlow or Cross or other AI tool. We can easily connecting with Python and Google Earth Engine for the lot of analysis possible. Okay, so now we'll try to explain this code how we can easily create for monthly or annually total precipitation. So this same approach you can also apply for this code. Suppose you can see we already create one map for this. Suppose I want to create for 2000 to 2010. Each year I want to calculate average temperature. 2000, what is the average temperature in Africa? 2001, 2002, 2003, all of this I just calculate for average temperature, or also monthly temperature, air temperature. So this type of things we are just use the same code to calculate this type of way. So first of all, if you check the information about the data, so basically these are charts. I take a variable charts and I put the image collection. So this is the image collection. I can easily get the image collection from here. You can see snippet. Simply copy, just copy. Then further, just I put my start and end year. Okay, start year I put 2000 and end year suppose 2021. Then I make a date object. Okay, so I create the start date and end date. So start date, so when you make any date object, we have to use the e date y from ymd. So ymd means that year, month and day. Start year I put the first and also first January, and in year, so if I just print, then you can also get idea. Print. You can see it print the date object. Okay, so it start from, you can see this time 2000 1st January, and if I just print the end date, just go. and run it, we find out, you can see 2020 to 1st January, because in the end year, so basically end year is the 2021. Then when I put the +1, so then 1 year, mainly 2001 plus 1, 22. We find out that 2022. Okay, 1st January. So we make the date object using that. So you can see it also date. So we just make the date object using this function ymd from ymd. And then we just make a list of the years. Okay, just we make the list of the years. So if I just print years, we just make the sequence, mainly 22 years. Okay, 22 years. So it will be start from 2000 to 2022. Okay, mainly 22 years. We find out that. So I want to create all of years annual total precipitation. So 2000, 2001, 2002, 2003, 2004, 2005, 2006, all of year. I want to calculate the total precipitation, as well as we also calculate the monthly precipitation. So just I put the stdr in here and also create the date object, and further we just make the sequence, mainly e.list sequence. Then we can put the stdr and in here. So stdr mainly 2000, in year mainly 2021. So we find out that total 22 years. Okay, 22 years. So just I make the sequence of the years and also make the list of with month. Okay, suppose I just put the month is that January to December. So just I put here 1st January to December. So just I make the sequence. So print. So you can see, you can get the total 12 months. Okay, one is January, then so all of month including in here. Okay. So after doing these things, in this case, just simply import your study area. Okay. Suppose if I just remove the previous study area, like the new study area, you can easily import your own shape file. Suppose just I simply import a shape file from the asset tab.
Sorry, sir. Sorry, sir.
Yeah, please.
I want to know how can you put a comment of the
Okay,
multiple
just
line
simply
at once?
select all of code, then put the control and forward slash.
Con-
Slash.
Control then slash.
Yeah, this symbol. Didn't
Okay.
really comment all of those. Okay, so I simply put the suppose I want to, yeah.
And to put a comment is the same thing. You highlight and put it. Is it?
Yes, same.
I mean, not to put to remove
Same.
a
Suppose
comment.
I simply put the control forward slash. So now I want to remove the comment. So just simply select and again press control.
Okay.
Let me import the Dhaka city bound. And I put the variable name. Name. So now the chart is created for our study area in Dhaka city boundary. We find out that annual total precipitation from 2000 to 2022 and also monthly each month. Okay. So now further we try to, okay. So now we just create a function which function help you to get the data annual, mainly annual total precipitation. So this code is very important because this code mainly try to create the annual image collection. So in this case, we are just use this function image collection from image. So basically, if you check your image collection in your charts, so if I just print charts, then it shows me that how So now it computed the total image. So we find out that 3,162 images. Okay, so 3,162 images. So this image collection I want to convert into 22 years image collection. Okay, suppose 2000, 2021, suppose 2000 total, 2001 total, all of yearly total precipitation I need to calculate. Okay, so I find out the total 3,162 images. So let's go try to calculate these things. So for that, just I use the function image collection from image. So basically this function you need when you suppose I have image collection. So this image collection I already have. So this image collection I convert into annual total image collection. Okay, annual total for each years I want to calculate. If you simply copy the function, just copy the function and also get the more details about that, just press on the docs tab, then you can get the more details. You can see this is the function we have using here. So return the image collection containing the given images. Okay, so in this time I have contains total 3,162 images. Okay, so from here I return the annually total precipitation image collection. So this is my main target. I want to calculate annual total precipitation image collection. And how much year? I already defined the year, how much year. Total 22 years. Okay, total 22 years. So for that, just I use the function image collection from images, and I create a function, and I create this function. So this function mainly I take the element as the year, and then I take a variable annual, and I call the charts. This variable stored total 3,162 images. This variable charts. This variable stored total 3,162 images. So this image collection I want to filter yearly. Okay, yearly. So I put the variable year and also year, and unit is the year. So basically in this time it filtered the image yearly from 2000 to 2021. Okay, total 22 years. Okay, and then I calculate the sum. So basically after filtering we are just calculating the each year total precipitation. After filtering we calculate the each year total precipitation, and then further we calculate the annual, set year, and system from year mandate. And further you can see this variable years. So this variable stored the total 22 years. This variable stored the total 20. If you check it from here, you can see years. This variable stored the total 22 years. Okay, so this is very important, because if you want to create, suppose I want to create this, I want to apply this code in my this study area. Suppose this I want to calculate the average air temperature for this time in this code. So you can just apply the same code also in here for calculate the or annual air you want to calculate. Same process. So just take copy and just try to show you that how we can calculate. So for that, first of all, you need to define the start year and end year. Just I set that start and end year. Also create the time object, and same process. Just I copy the same code. Just copy, paste in my code. And further, just copy. And paste here. So in this case, you can see, suppose I want to create this time series chart from 2000 to 2021, or I want to calculate suppose 2000 to 2010. Just put 10 years that I want to calculate. So just 2010, and further say I want to get down. Now further, I just need to call this variable. Okay, so his variable is stored in my data set. Okay, suppose you can see, I just try to put here the 2000 to 2000, suppose 2010. So this variable store it. Okay, and further this dataset I also convert the unit and store it in here. Just a copy element to set as in paste here. Now further it calculate that I want to calculate for average annual air temperature. To put here the mean. All of those are the same. Just if I just print variable can be just I run it. So now it compute yearly. We find out from here. Yeah, so here you can see, okay, I think it's the biggest study area. For the biggest study area, we try to learn about the CSV. How we can download the CSV directly from here. We also because when you want to make that the time series chart for the biggest study area, then you have to use the CSV. You directly download the data CSV. So if you check the result, you can see working. Okay, so it create, you can see total 11 element. Okay, when I print that, I find out the 11 element. 11 element means that total 11 years. Okay, total 11 years. So if you check for the properties, we find out that 2000. Okay, also check for that another, we find out that 2001. You can check that, we find out that 2002. So now we have to create the annual average. We can, because I put at the mean mainly calculate the average. So we calculate the annual average air temperature. Okay, so just a convert, you can see. So first of all, I have total this image collection. Okay, this image collection I just take only for the year of 2000 to 2010, mainly 11 years. We find out 11 years. So now I want to use this 11 years mean or average temperature result and make the time series chart. So same code we also use in here for creating this time series chart. Suppose just I copy and paste the code in my code. Now after this is the chart code about that. So I take a variable and just call UI chart image series by regions, and then my image collection, this variable I just using that same variable also in here. Region means my shapefile variable name. This is ROI. I want to calculate the mean and also call the band name. So basically my band name is that, you can see temperature 2 meter. Copy and also here. So change the scale. Scale means the resolution of your data set. So in this case, my data set is that data set. Now we try to check. Okay, set option. Okay, mainly title. We just also in here the title. Suppose the title, just like title. Title. Annual air temperature. Paste. So you can easily find out this type of result. For 2000, you find out that 24.8. It's the average temperature. We find out that 2001, 24. Okay, 24. Not much very find out that we find out that high temperature 5 and also low, find out that the year of 2010. Okay, so it show about the annual air temperature. So now how I can clear the monthly? Suppose 2000 all of month, 2002 all of month, 2004 all of month. So how we can apply? So before starting, just we take a break for 5 minutes, then we start come back in. Just take the break 5 minutes.
Okay. 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 Thank you.
Okay.